Hey everyone, and welcome back to the channel. Today, we're diving deep into a topic that's revolutionizing how we build and deploy applications, especially for our Java microservices, automating infrastructure as code with generative AI. Modern software development, particularly with Java microservices, demands incredible agility and precision. Each microservice often requires a unique ecosystem of cloud resources, databases, message queues, compute instances, networking configurations, and more. Historically, provisioning this infrastructure has been a bottleneck, a complex, manual, and often error-prone process. This is where infrastructure as code, or IAC, stepped in, allowing us to define and manage our infrastructure programmatically, just like application code. It brought consistency, repeatability, and version control to infrastructure management, transforming manual provisioning into automated, reliable processes. But what if we could automate the creation of IAC itself? That's the powerful promise we're exploring today, laying the groundwork for how GenAI can take IAC to the next level for your Java deployments. Now, let's talk about the reality many of us still face. Imagine you're developing a suite of Java microservices. Service A needs a PostgreSQL database, a specific Kafka topic, and runs on a Kubernetes cluster. Service B requires DynamoDB, an SQS queue, and deploys as a serverless Lambda function. Multiply this by dozens or even hundreds of services, each with its own set of requirements, and then factor in different environments: development, staging, production. Manually writing and maintaining distinct Terraform or CloudFormation templates for every single variation becomes a monumental and incredibly tedious task. It's a breeding ground for inconsistencies, configuration drift, and human error. Developers spend valuable time fiddling with infrastructure definitions instead of focusing on core business logic. This manual overhead creates significant friction, slows down release cycles, and makes scaling Java microservice architectures a constant uphill battle. This is the pain point that GenAI aims to alleviate. This is where generative AI emerges as a true game-changer in the IAC landscape. Generative AI, at its core, refers to algorithms that can produce new content, whether it's text, images, or even code, based on patterns learned from vast datasets. Think of large language models, or LLMs, that can understand complex natural language prompts and generate coherent, contextually relevant output. When applied to infrastructure as code, GenAI shifts the paradigm from manually crafting every line of configuration to intelligently automating the generation of those definitions. Instead of writing boilerplate code repeatedly, we can instruct a GenAI model to construct the necessary infrastructure based on our high-level requirements or structured inputs. This leap in automation promises to make IAC creation not just faster, but also more accessible and significantly more efficient for managing our complex Java application ecosystems. So, how does this magic actually happen under the hood? Generative AI models, particularly advanced large language models, are trained on massive repositories of existing code, architectural patterns, cloud provider documentation, and configuration files like Terraform and CloudFormation templates. When you provide a prompt, for instance, deploy a Spring Boot Java application on AWS Fargate with an RDS PostgreSQL instance and an application load balancer, the GenAI model processes this request, understands the underlying components and their relationships, and then dynamically constructs a new, valid infrastructure definition. The quality of the output is heavily influenced by prompt engineering, how precisely and clearly you phrase your request. Furthermore, providing structured inputs, such as a JSON schema outlining your desired service, dramatically enhances the model's ability to generate accurate and perfectly tailored IAC, ensuring your Java microservice gets exactly what it needs. While natural language prompts offer incredible flexibility for highly precise and consistent IAC generation, structured input formats like JSON or YAML are often superior. Imagine defining your Java microservice infrastructure requirements not as a vague sentence, but as a clean, hierarchical data structure. This could specify the service name, its compute requirements, e.g., AWS Fargate, Lambda, or a specific EC2 instance type, database needs, e.g., PostgreSQL with a particular version and size, or DynamoDB with specific throughput, messaging services, e.g., Kafka topic details, SQSQ configurations, and even network policies or scaling rules. This structured input provides the GenAI model with unambiguous parameters, minimizing misinterpretations and hallucinations. By leveraging a defined schema, you ensure that the generated Terraform or CloudFormation templates are perfectly aligned with your architectural standards and the specific needs of your Java application, streamlining the entire deployment process and significantly reducing potential errors. Let's talk about Terraform, the multi-cloud maestro of infrastructure as code. Developed by HashiCorp, Terraform uses its declarative language, HCL, HashiCorp configuration language, to define infrastructure across virtually any cloud provider, be it AWS, Azure, Google Cloud Platform, or even on-premises environments. For Java microservice deployments, Terraform's vendor-agnostic nature is a massive advantage. It means your teams can use a single, consistent toolset and language, even if your various Java services are deployed across different clouds. Its robust state management ensures that Terraform understands the current state of your infrastructure and only applies necessary changes, preventing unintended modifications. Furthermore, its module system promotes reusability, allowing you to encapsulate common infrastructure patterns for your Java applications. GenAI can now dynamically generate these precise HCL configurations, tailored for any cloud, accelerating your multi-cloud Java deployments. On the other side of the IAC spectrum, specifically for those deeply embedded within the Amazon Web Services ecosystem, we have AWS CloudFormation. CloudFormation is AWS native infrastructure as code service, allowing you to model and provision all your AWS resources using simple text files in YAML or JSON format. For Java microservices exclusively deployed on AWS, CloudFormation offers unparalleled integration with other AWS services. It provides robust rollback capabilities, enabling you to revert to a previous stable state if a deployment fails. Its drift detection feature helps identify manual changes made to resources outside of CloudFormation, ensuring your infrastructure remains consistent. Beyond this, CloudFormation seamlessly integrates with AWS CI/CD services like Code Pipeline and Code Deploy, making it an excellent choice for automating your Java application's release process. GenAI can produce highly optimized and idiomatic CloudFormation templates that leverage AWS-specific services crucial for Java applications, such as Elastic Container Service, ECS, AWS Lambda, Amazon RDS, SQS, and SNS, streamlining deployments further. Now, let's stitch it all together into an automated workflow. The process begins with a developer defining their new Java microservice infrastructure requirements. This could be a simple, intuitive JSON or YAML configuration file, or even a natural language prompt describing the desired setup. This input is then fed into a generative AI service, which could be integrated directly into your existing CI/CD pipeline. The GenAI, powered by an LLM, processes this request and dynamically generates the complete, ready-to-use Terraform or CloudFormation template. This generated IAC code isn't deployed immediately. Instead, it undergoes a crucial review stage, often as a pull request in your version control system, like Git. Once approved, the IAC template is then automatically applied using the respective tool, be it the Terraform CLI or CloudFormation CLI, to provision the actual cloud resources. This end-to-end automation drastically reduces manual intervention, accelerating the entire infrastructure provisioning cycle. The benefits of this GenAI-powered IAC automation for Java deployments are truly transformative. First and foremost,